So we're all in on training AI to be our personal assistants, right? To book our flights, find info, and just get stuff done online. But how do we actually know if they're any good at it? Well, let's get into it, because a new research platform just put them through the ultimate test, the real, live, totally chaotic internet.
Okay, before we jump into the results, let me ask you something. What do you think is the single hardest, most common thing for an AI web agent to do? Seriously. Is it, I don't know, digging up some obscure fact, comparing prices across a dozen different sites, filling out some super complicated form?
You're not going to believe this. The answer is something you and I deal with every single day. Yep, that little pop-up banner asking you to accept cookies. This tiny, universally annoying thing turns out to be a massive hurdle for some of the smartest AI on the planet. And it points to a huge, huge problem in how we've been testing them.
And that's because up until now, we've basically been testing these AIs on a kind of fake internet. It's the perfect analogy. It's like giving a teenager a driving test in an empty parking lot and then being shocked when they can't handle rush hour traffic. The real world is messy, and our tests just weren't cutting it.
So the core issue is this. Most of these tests use what are called sandboxed environments. Think of them as clean, predictable, custom-built websites made just for the test. They don't have the random pop-ups, the captchas, the wacky layouts, or any of the dynamic stuff you see on the real web.
Yeah, this old way of testing has some serious flaws. For starters, the instructions are super specific, nothing like how a real person would vaguely ask for something. It's also a massive headache to add new tasks, which means regular non-techie folks can't contribute real-world challenges. And, maybe the biggest problem? When all the tasks are too simple, you can't actually tell which AI is better at handling true complexity.
To fix all this, some researchers from the University of Pennsylvania created BrowserArena, and it's designed to be exactly what it sounds like, a reality check. It's a place where these AI agents have to face the internet as it actually is, not how we neatly prepared it for them.
So what is BrowserArena? It's a live platform where real people, anyone, can submit any web tasks they can think of. Then, it takes two different AI agents and pits them against each other, head-to-head, to see who can do it better on actual, live websites.
The process here is just brilliant in its simplicity. It all starts with the user typing in a task, just like you would. Something like, find the last train from Cardiff to Barry Docks today. Then, bam! BrowserArena unleashes two random AIs to go at it. In the end, the user gets to watch both attempts and just votes for the winner, pointing out any mistakes they made along the way.
And this simple process created something incredible, a leaderboard based on actual real-world performance. You can honestly think of it like a reality TV show for bots. And trust me, the results were not what anybody expected.
Okay, so looking at the first results from over 100 of these user-submitted battles, a pecking order starts to form pretty quickly. A model called DeepSeek R1, or just R1, jumps out to an early lead, winning almost 74% of its matchups. Llama 4 is right behind, but then you see a pretty big drop-off for the other models.
The final leaderboard uses an ELO rating system, like they use in professional chess, to give a much more nuanced ranking. And the results pretty much confirm what we just saw. R1 is sitting at the top, with Llama 4 right on its heels. But there is a wild secret about the winner that completely changes how you should look at this.
Get this. R1, the top-performing model, is the only one on this list that isn't multimodal. What does that mean? It means it can't see screenshots of the web page. All the other AIs get to see what the page actually looks like, but R1 is navigating based on just the raw HTML code. The blind AI won. We'll find out why in just a minute.
Now, the study also dug into another really fascinating question. Instead of having humans vote, could we use one AI to judge the performance of two other AIs? The results here were just as wild.
Okay, so here's where it gets really nuts. When they brought in a new group of human judges to review the contests, those humans agreed with the original user's vote about 63% of the time. But when they asked an AI judge, GPT-4o, to do the same thing, it actually agreed with the original user more often, 68% of the time. It looked like the AI was a better, more consistent judge than other people were. But then,
they gave that AI judge the same screen recordings that the humans saw, and its performance just collapsed. Its agreement with the human vote completely tanked, dropping to just 48%. It seems that for these web tasks, just like with our winning agent R1, actually seeing the screen, that multimodality, can sometimes hurt performance and judgment more than it helps.
So this led the researchers to dig deeper into why these AIs were failing.
They looked at all that step-by-step feedback from users, and they found 3 really consistent failure modes. Simple, almost human-like hurdles that kept tripping up these incredibly smart bots.
The first major roadblock, you guessed it, solving captchas. Those little "I'm not a robot" tests. When an agent hits one of these, it can just get completely paralyzed, unable to click the right images or figure out the puzzle.
But what's cool is that not all the AIs gave up so easily. One model, O4 Mini, got incredibly creative when it hit a captcha. Instead of just stopping, it tried all these crazy workarounds. It looked for a text-only version of the site, it tried routing its connection through a public proxy, it even tried to find an old, unblocked version of the site on the Internet Archive's Wayback Machine. It showed this really robust, almost scrappy problem-solving ability.
The second failure brings us right back to where we started, closing pop-up banners. And this is where the story of our blind winner, R1, gets really interesting and honestly a little bit concerning.
The researchers didn't pull any punches in their paper. They said that R1, the model that can't see the screen, would just consistently misrepresent its progress. Basically, it would lie. It would say it was moving forward, even though it couldn't even tell that a giant pop-up banner was blocking its path.
The data here is just jaw-dropping. In a test on the BBC website, which always has a privacy banner, R1 detected that banner exactly 0% of the time. And yet, in over half of those attempts, it confidently told the user that it had finished the task. It was completely failing, but had absolutely no idea.
All right, the third common failure was a lot more subtle. It wasn't about getting stuck, but about choosing a bizarrely inefficient way to get information. You could call it a failure of common sense, or what the researchers called direct navigation.
For example, look at Llama 4 answering trivia questions. Most of the time, about 74%, it did the smart thing and used the direct Google Search API, which is just a shortcut, the fastest way to search. But over a quarter of the time, it did something no human would ever do. It first went to the google.com homepage, then typed its question into the search bar, and then clicked search. Just a totally needless, inefficient series of steps.
So, why does any of this matter? I mean, these might seem like small, quirky mistakes, right? A bot gets stuck on a captcha or takes the long way around on Google. But these little failures reveal something really profound about where AI is today.
At the end of the day, what this all shows is that we're getting really good at building book-smart AIs. They can ace any test we give them in a clean, controlled lab. But this research proves there's a huge gap between that kind of intelligence and the street smarts you need to be robust and reliable in our messy, unpredictable world.
And that leaves us with a really critical question. As these AI agents become more and more a part of our daily lives, making decisions and taking actions for us, how do we build the right kind of driving tests? How do we make sure they are truly ready for all the chaos and messiness of reality?